Hello. So I'm going to show you how to create a basic state machine from the boilerplate code that Godot 4 provides us for a character body, specifically the character body 2D, but these concepts can for the most part be applied straight across for a 3D situation as well. A lot of tutorials obviously are a bit obtuse when it comes to talking about state machines. So this is basically the most simple version of a state machine to hopefully make it a little more clear for some people. So I'm going to go ahead and start by creating a 2D scene. And it's just a regular old generic node 2D there, which acts as the top parent node. It's otherwise fairly inert. I'm going to just go ahead and rename that to world. That's effectively what it is here for the most part. But if I hover over it, we can still see it's a node 2D, of course. I won't be explaining a lot of this detail behind. It's assumed that you have at least a very basic knowledge of, probably followed one or two tutorials to get a little hello world or basic video game going. So with that assumption, I'll continue. I'm going to add a child node, and I'll go ahead and add a static body 2D to act as the floor, and it's asking me to create a collision shape, which is pretty typical. So I'll go in and find a collision shape object or node and throw it in there, and then of course they want me to provide an actual shape. This is all pretty boilerplate here, so I'm going to go ahead and set this to world boundary. If I switch back over to the 2D, we can see here I have my dimensions set to 320 by 240, and then I'm upscaling that to 640 by 480. Again, this should be applicable to any dimensions. Alright, so I'm going to go ahead and group these two together so that when I select one or the other, I select them both, and so they don't get out of sync with each other, and then I can move this down here. And then I'll go ahead and create a character. And sorry for going through every little detail here, but I just want to show exactly the base that I'm working with rather than starting with these nodes just in case to avoid any ambiguity. Okay, and again, this one also needs a collision shape, so I will go ahead and add another child node. And again, I'll add a collision shape 2D, but this time for its shape, I'm going to go ahead and make it a rectangle here to represent the shape of the character body. But before I do anything, I'll click back there. I'll group the two nodes again, just like I did before, so that the character body node moves together when I move it like this with the collision shape. Otherwise, they could end up apart from each other. I'm going to zoom in a little bit here, and I'll go ahead and if I specifically select after they're grouped, since I can't select them individually, I just always end up selecting the parent with that grouping. I'm going to go ahead and specifically select this in the node tree, and then you can see it gives me the handles because it does allow me to specifically select it over here. So I'm going to do that. And then of course, in that case, no, I can't move it. I thought maybe I could move it individually. Or it looks like maybe I did. Those two centers are off. Is that just because I made it a rectangle? Okay, I'll stick to the script here. Okay, I'm going to move that there, select that so I can get these handles. Just give it a little bit more rectangular shape like maybe a player would have. And then instead of going in and adding the sprites and all that kind of stuff, I'm just going to go here and I usually turn off remote debugging, side note, just as a lower potential attack surface, I don't know. And then I want to make sure that visible collision shapes is checked. If that's checked, then when we hit play, we will be able to see. I'll go ahead and do it. I'll select this current scene, which is this whole scene right here, this unsaved scene. It's saying which one do you want to use when you hit play. I'm going to say select current, and it's going to ask me to save it. And I'm just going to click save. We'll save it in the folder I've designated for this project. Okay, and here we go. I'm running the player embedded. If you want that in your little floating player, you can just uncheck this and rerun it. Okay, and then of course nothing happens if I were to press anything because it's there's no sort of behavior attached to it. This is just like a static scene, so to speak. Okay, so I'm going to click stop, and then what I need to do is I need to attach a script to the player object, to this character body here. So I'm going to attach that script. I'm going to go ahead and leave everything checked or default and make sure that it has this character body 2D basic movement, that little generic template for that type of a node. And I'm going to click create. The name doesn't really matter. I'm just going to leave it at the default. Of course, in a big project, you want to have a meaningful name, probably. I'm going to click the output to get rid of this tab for now. And then we can see here that, zoom this in a little bit just to ensure it's hopefully more legible. Okay, so this is just the default generic script that it attached right here. And I'm going to hit play, and this will give us magically the movement of our character, which hopefully a lot of people already are comfortable getting this far. I can hit spacebar to jump, I can use the arrows to move, I can move in the air. Alright, that's, for the record, that's what we can do here. And it lands on that little static object 3D that goes infinitely in both directions that acts like a floor. Anyway, I'll hit stop. And now what we want to do is we want to, this is, as we can see, this is just a big if-else kind of clause. There's not even really else's. It's just, you know, add the gravity, which this is basically saying we're going to fall, right? Fall. Because that's what adding gravity does, is it tries to fall. And then handle jump here is saying, you know, if they're pressing UI accept, which is pre-configured into Godot as a spacebar, of course that's configurable. If they're pressing the spacebar and they're on the floor, then we're going to jump. So, of course, we can just simplify this to jump. And I'm going to go ahead and get rid of that. And then this one, what's going on here is it is for move left or right. I should put move left or right. We're probably not moving both directions. Okay, move left or right, jump and fall. So if we think about it, we basically have three states here, right? So yeah, it's a very simple case. And then no matter which one of these is happening, it can be combinations of them too. This could basically be like an else if to this one, because you're either jumping or falling. You're not doing both. And in that case, if not on floor has already been tested, so we could really just get rid of that. And I can demonstrate by showing that this behaves exactly the same. Okay. And I apologize if it's a little choppy. I'm recording this at only 20 frames per second. So anyway, yeah, but I'm going to go ahead and revert that back to how they had it, because ironically, the way they coded it is actually better for state machine coding, because this will be more typically, it could come independently of fall. So by just having them as separate if statements with all the necessary clauses in there, then they're more independent. They can be separated from each other. But doing that else if you're going to keep this traditional basic structure, that might be a little more simple and efficient. Okay, so other than changing the comments so far, everything's identical. So what we now know is there's a state to refresh. To refresh us, there's a state, and there's a state. And then no matter what, after any state, we want to call move and slide, which will, these basically load the physics. They load the velocity for the up and down. This is velocity for up and down. Here, this is velocity for left and right. And then calling move and slide acts on that. And possibly other factors like the hitting the ground and whatnot in the environment. Okay, sorry to be so long-winded with this. So now what we can do is basically for physics process, we want move and slide in there. We're going to do it. We're going to do the thing. So it should behave, hopefully, when we're done, exactly like it did. I'll go ahead and do the two spaces between. which is just a Godot styling convention, and then replace this comment with a function name, func fall, and it gets the delta, just like how physics process. This stuff's actually unnecessary. That's just to have complete types and everything, which I typically do when I code with GDScript, but it's, just in case somebody isn't, I don't want it to be confusing, so I'll get rid of that. So it was just saying what type delta is, it's a floating point number, and then that arrow to void was saying we don't return a value from the function if it's called. We just run the code in it and be done with it. Okay, so fall, if not is on floor, what's it complaining about? Down here it says unexpected indent in class body. Oh, it's because I don't have a colon there. Okay, good. And then physics process, what we want to do is we want to call one of those states. State, and we want to call it with delta. Right? So what we're going to do is we're going to have a variable up here called state. And if you were doing types, you would need to make sure it was callable like that. And then we're going to set the first one, we'll call it walk. Which, walk here, we're going to keep it simple, and that state's going to represent just standing there or moving left, right. So any of those three conditions. And again, since I'm just keeping it simple, I'm going to go ahead and get rid of the callable part. And it's upset because I don't have a walk function yet. So maybe I should go ahead and create that. And I'll do a func walk. And it's going to have that same signature, have the delta. And then here I'll just do a pass for now, which says, hey, we'll write the actual code later. All right, and I'll save that. And state is not a function. So that is, whenever we use a function in GDScript, like a variable, we have to actually call it. We have to do a dot call, like that. It's the same with lambdas, if you're familiar with those, which are like little functions we build in place sometimes to act like little temporary functions or variables. It's the same type of syntax as that. So since we're using these like variables, because up here it's getting assigned to a variable. So on that variable we have to, because Godot wants to optimize the way that it runs, it doesn't want to constantly do extra checks that some languages like Python or something might do for us, which actually slows them down, because every time we access it, it goes, oh, does this have this interface on it, blah, 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 all this stuff behind the scenes. Godot just says, hey, if you want to treat it like a function, you have to be explicit about it and say call. So anyway, that's what we're doing, and it acts just like, with a regular function. Again, if that call wasn't there, it acts just like that, but we just have to be explicit. Okay, so we're going to start out in the walk thing, and what we're going to do for walk is I'm actually just going to say return here for now, because all we want to do is, like for instance with this, if we disregard all of this stuff for now and just consider this stuff, then if we're going to call walk because it's the default one, and then after we call walk, it's just going to return and it's going to call move and slide. So what we actually need here is we need this functionality in walk. But we know that we need that functionality for fall and jump and all the rest of them. I'll go ahead and just function jump delta, make that less confusing there, more consistent. Okay, and then I'll go ahead and put the double spaces to be nice and follow the GD style guide. Okay, yeah, and then here we're gonna make this a function too, and I'll just call it move left right, and it actually is an exception. It doesn't need the delta, because for one, if we notice this code, delta isn't being used anywhere, or else I would go ahead and pass it in. And also, it's not going to be a state. It's just a helper function that any one of these states can call. The states, though, will be the name passing in delta. And then, of course, we get delta from physics, from the Godot engine. It calls physics process once every 60 times per second or whatever. And then we come in here and we just pass that same variable into state.call, whatever that happens to be. Initially it's walk, and it's going to return. That's going to call move and slide. In this case, since I know that when we're falling, we want to be able to move left and right like we originally did. When we jump, we want to be able to move left and right. And of course, when we're walking or standing still, we want to be able to have the left and right functionality as well. So in that case, I can just call move left right. I could put, if only some of these states needed it, I could just put it at the end of each one of them. But in this case, since I know that all of them need it, just like they all need move and slide for this simple situation, I'm going to go ahead and just put it there to reduce redundancy. Okay, and we're almost there. So now the only issue is we have like if not is on floor fall. Well, or if they're pressing this, then jump. Well, this is the jump state. So whenever we end up in the jump state, we should probably already know that this has happened. And what we do now, if I open up a graphics thing here, which one of these would be good for drawing a few states? I don't know, probably picking a bad one. Okay, I'll go ahead and sorry about make that black. Go ahead and get a nice green color here. Do we have squares? Is that what this is? Let's go full screen here. That didn't do us much good. Maybe not full screen. Oh, I don't want to be too... Sorry, I should have practiced this part. I didn't realize it. Okay, I'll pick this square. And that's not it. What do we have here? Make a selection. Do you have shapes? Okay, maybe not. So this is going to be rough. We're just going to have a state here. And then we're going to have a state here. Actually, I'm going to change the color of each one. Apologize, they're so ugly. And, man, is there really no sort of, does this do it if I hold it? Transform color, okay. Accept the fact that they are ugly and move on. Okay, so here's our three states. We have jump, walk, and fall. So now I'll switch this back over here to, I guess, black, and I'll pick the text. Sure, that works. Oh, does it work? Do I have to type text here? Okay, so we'll call this one fall, or I'll do it all lowercase to be consistent. Fall, paste, fall. All right, and jump. Oh, what happened to fall? Oh, I guess I have to like hit enter or something to confirm it. Let's see if we can hit fall. There we go. So I have to like hit a key or something to confirm it. And then we want walk. All right. And then from here, if we go back, or just, we don't even have to go back. Let's just consider which states will want to switch between which one can transition to which other one. So we could go from falling till we hit the ground, and in which case we'll want to, how do I put that? Maybe on a littler guy over here. So from fall, we might want to go to walk. If we're falling straight down, we hit the ground, we want to go to that walking or standing thing. From fall to jump, we're not doing a double jump, so we're keeping it simple, just like it is out of the box with the GDScript template. So that's not a thing. Okay, so what about from walk? From walk, we want to go to fall. Maybe, if we had like a platform that we could fall off of, we could walk off of that. So we'll go ahead and just put that one in for good measure. What about from walk to jump? I think we definitely need that one. So there's a transition we need. Okay, what about jump? Do we go from jump to walk? We're already calling move left, right, no matter what, so it's not like walk. We don't need that state for that functionality. But if we jump, eventually we hit the apex of that jump and we fall. So that's a thing. So we'll go ahead and indicate that with an arrow here. So now we have our state changes. And I went ahead and kept them consistently colored to show that when we're in the fall state, we could potentially transition to walk. When we're in the walk state, we could potentially transition to either of those two states. And when we're in the jump state, we could potentially transfer to fall. So that's nice. That's 4 conditions that we need to worry about. One of them is a duplicate condition because we can see, let's see, there's a unique color here. We can see here that we have 2 states that go to fall. And in that situation, they're going to use the same logic to determine whether or not they need to go to fall. So, in other words, that means we have 3 separate transition conditions or code, as you'll see. So I'll switch back over here. And that's these, like this right here, this code that originally, in the original script, determined whether or not we were should jump. That will now determine whether or not we should transition to jump. So I'll cut it out of there. And looking at our thing, we need to transfer to jump from walk. So I'm going to put that into walk here. So now if those are all the conditions for walk, then we should be walking. So we need to set the state variable equal to walk instead. And in that case, if there had been code down here specific to walking, we would not want to run that, right? So anyway, in the typical case, we'll just return. We'll abort. So it's here we are checking. This is just a comment. It doesn't do anything besides talk to us in plain English. Check if we should jump, and then if so, we want to change state, and after we set the new state, or I could say, I'll just leave it as change state, then we want to abort before running, I'll say abort without running walk code. Alright, and then of course, no matter what, walk just returns. So I could even just get rid of that return statement. It functions in GDScript will just, unless you need to return a value specifically. Otherwise, this one's essentially like that, which means it doesn't need to return any value. Okay, so that's all walk does, is check if it needs to transition to the fall state, or excuse me, to the jump state, but we can see it also needs to transition to the fall state, so we'll also take care of that. And it's a lot the same here. As you might have guessed, hopefully. So the fall state, here's the condition for the fall state, and we are going to check if we should be falling with this. If we're not on the floor, then we're in a standing or walking state, then that means we should be falling instead. So if that's the case, we basically want to do this same stuff over here. And instead of switching to walk, of course, we'll switch to fall. Alright, but it's otherwise pretty much the same thing. Save that. Okay, so that covers both of those arrows. Now for jump to go to fall, we can copy that same fall code we used here. And I'll jump back over here. And here is that check if we should be falling code. I'm going to copy this and I'm going to go down to jump here. I'm just going to paste it right in there. And then what we have here is effectively, this is also still part of the jump function, the jump state. We're going to say otherwise go ahead and jump. And I really should put a space there, but just to keep it compact and make sure that it's, for some people they might get confused when there's extra spaces. But if we're strictly following the GDScript styling guide, which is similar, adopts a lot of principles from Python's styling guide as well, we should have a full space after any sort of block of code, after any sort of indented code. When we dedent back, that space is supposed to help us really cognitively lock in the fact that it's like not part of the previous block. Okay. But yeah, I haven't done that for here. This would be appropriate if this was an else if, which it could be. We could just as easily, we could do that and that would be fine. But since we're returning, we don't need to, because it's automatically, these are all terminating conditions. A lot like recursive functions, functional programming, if you're familiar, you put the terminating conditions at the top of the function, even though these aren't recursive, because if we were to call these recursively, that's also the reason I'm returning. And if you're thinking like, why don't I just call walk, and instead of changing the state, why don't I just call walk here, and then and say return walk, like why don't I just instead just do something like this, like return walk, like that. And then eventually, okay, I won't get off in the weeds. I'll just answer this question. So if we do this, that might work maybe most of the time, but what tends to happen is if we move around a lot, we can end up in this case where we're like constantly calling new functions. Like as soon as we call walk, I might actually hit the jump button. And anyway, if you want to experiment with it on your own, just do a bunch of movements really rapidly, and you should end up with a Stack Overflow, because what it will be doing is it's constantly calling those functions and it's never able to fully unwind from them. And that's why I'm not doing it like that. That's why I'm doing this way that might seem a little bit less elegant. Another option here too is to just return, is just to say like state equals state, and instead of I could just return walk here, right? And then not even use that. And then if I end up running the actual thing, like down here, I could just return, like in this case, I would just return jump if I return the same state. In any modern system, in this century, it might seem like, oh, we're setting the state even though we don't need to. Isn't that inefficient? And if you think about all the variables that we're constantly setting every frame, that's nothing. So it's not a big deal. But yeah, I'm just choosing to do this. This is arguably the simplest way, but that is another totally valid option to do. Okay, so what do we have here? We have walk calls its two states, jump calls its checks anyway, if it needs to change to the false state, and then it returns. And so one other concern you might have is, which I think would be a valid concern to have, is like, why aren't we like skipping a frame if we return it? Shouldn't we set up some system to like check if state changed and wasn't called and then we need to call this change state so that it actually happens this frame? Again, I think that's a perfectly valid question to have, but there's a little trick. Just like how I mentioned that at the beginning of this video, I'm recording it at 20 frames per second. It's not directly connected to that, but 20 frames per second is good for a lot of things. It's good enough for a lot of things. And video game input happens to be one of them. There are a lot of video games that only register inputs and change the behaviors at 20 frames per second, even if they're actually quote unquote operating at a higher frame rate. It's not like they're slowed down to 20 frames per second, but they're only effectively doing the thing 20 times a second. Zelda Ocarina of Time on the Nintendo 64 is a famous example. It might even be doing some things less than 20 frames per second. But anyway, a lot of things are. And if you consider typically a Godot video game is going to run at around 60 frames per second, that means that's 3 times as many frames as we actually need to have to be sufficient for a video game. So in this case, in theory, it's still performing that check 30 times a second, because it's at least 30 times a second. So that's well above the threshold of what's needed, and that's why we can get away with it. I've never seen it cause a problem. Maybe, I don't know, if you have a super duper responsive video game, maybe it could cause a problem, in which case you would probably have to add that special if else. But otherwise, keep it short and simple. Don't do anything unnecessary until you for sure need it. Like, try this way first for sure. And this is also a good step towards, even if you want to end up using objects and abstract classes and whatnot for your state machine, I think if you're completely unfamiliar with state machines, this is a good way to start out and use this as like a transition point. Pun not intended, as far as state transitions, but to get there. Okay, I'll shut up and finish what I've started here. Okay, so we have the jump switches states. Fall needs to switch states to what? And I definitely recommend drawing a little diagram like this for all your states so that it's much easier to visualize than to just have your eyes glaze over staring at the code. So fall needs to transition to walk. Okay, so we can go snag a walk anywhere out of here if I have one. Should be falling, should jump, should be falling. I don't have walk code because that was always just implicit, because it's basically just move left and right and move and slide. So rather than stuffing those conditions in move left and right, and if in case you're wondering why I didn't just make that a state, again, it's because each of these other states needs to call it. So I don't want to put the terminating logic. This should be more like neutral, right? This should just do the thing no matter which state we're in. So we're actually going to have to create one more state, which we already did for walk here. And then we need to put the condition for that. So what is the condition for walk? That is on ground. Was that the only one? I'm just thinking here for a second. If is on floor, then we want to walk. I'll try that one out and see. I imagine it should work. If is on floor, then in that case, we want to stop falling, right? Go ahead and back that one up. Okay, if is on floor, then we want to stop falling. I guess if I would have thought from that direction, what would be the case where we want to stop falling? When we hit the ground. Okay, so in that case, we will set state to equal to walk. And even if we're going to hit jump exactly when we hit the ground, it's okay to go to walk, because when we go to walk and it's called on the next physics frame, it will immediately check if we're pressing jump or not. So that should all work out well. And even if we think about it, it's like, oh, this will skip a frame. This will skip a frame. We're still 20 frames per second on the input in that case. So that should be fine. Alright, and then I need to return to abort. And then otherwise, we'll go ahead and run the velocity. And I'll just leave that one without comments. Maybe I'll even leave that little space in there too. Okay, so there we go. Hopefully this code's mostly readable, self-documenting. Function fall using delta. If is on floor, state becomes walk, return. And otherwise, velocity gets added to. That's what this velocity equals velocity plus gravity times delta. So it will calculate gravity times delta and then add that to whatever the velocity happens to be. So we'll just continue falling. So if you wanted to, of course, you could just say, put a comment there, something like continue falling Something like that would be fine. Alright, and I'll just double check this. Jump. Yeah, go back over here. We've got our one transition from fall to walking on the floor. This is all boilerplate code, so it shouldn't have to change unless, of course, you're fine-tuning it for your own video game. And that's what this should set us up for. And I believe, unless I'm missing something obvious, which I probably am. What's this say? Nothing? Am I just on that line? Okay, I'm going to go ahead and hit play and see if anything happens. Something's going to happen. Let's see if it's good or bad, in other words. Okay, so far so good. Jump is not working. What's the debugger have to say about this? Reload delta is never used in walk or jump. Okay, maybe that's a clue, so I'm going to... the arrow keys are working left and right. I remember that happening to me before when I tried this, the very first pass. Okay, I'm going to shrink that down. Okay, delta is not used in jump. Fall uses delta. Move left, right doesn't need it. Walk doesn't need it. Anyway, that's just a warning. I could do the whole thing where I add the underscore, because even though it's called delta out here, we could rename it to whatever we want. We could just call it D or something if we wanted to in here. I'll go ahead and just add that for good measure. I'm not a big fan of that. I usually dig into the settings and just tell it not to warn me about that because I think it's a little bit jank personally. But anyway, I just need to double check. So jump wasn't happening while we were walking. So is action pressed and is on floor state walk. Why did I set that? I meant to do jump there. Everybody's probably known that for a long time. Okay, because I must have copied and pasted that code, which of course is one of the dangers. Return without running walk code. That's the right comment. Return without running walk code. That one would be jump. Yeah, again, of course, that's the danger of copying and pasting code, is forgetting to customize it. And also, that's a code smell or a code scent, which tells us we're duplicating whenever we're copying and pasting, which means it's a candidate for putting in its own little helper function, breaking it out into its own little helper function, because we're repeating that code. We could just say, like, we could call this, like, if not is on floor, right? That's what it is for both of those. So we could just name it to, like, in air, is in air or something different, right? That wouldn't conflict with this. And then we could put all of this code inside the is in air function, and then that could return a true or false. And then we'd only have one place where we change this code, and we wouldn't have to worry about, changing it in multiple places. Anyway, let's check it out now. Alright, I'm jumping and moving just like before we refactored to a state machine. Okay, so it passes the test. So that is that. We added the state, the sort of a global, not global across the whole program, but global for the script variable. Maybe I should just call it a script variable. It would be like a member variable, considering that this is an object, which if we wanted to, we could give it a class name, character, or player, or whatever. And if I'm going to do that, I'll go ahead and change it here as well to character, make it a little more consistent. And then I can even shrink those down like that, make it a little cleaner looking. I'm going to name this one floor. Did I spell that right? Alright. But yeah, we added this variable, added this for good measure. You don't even have to do that. The physics process is this simple now. That's all of physics process. It just calls whatever the current state happens to be. Then it loads up any left or right velocities right in there. And then it calls the built-in move and slide function, which will, of course, finally execute based on all these physics variables and values we load up. We have the function walk here, We don't even have to have that underscore if we don't mind getting the little yellow flag about it. Check if we should jump. So yeah, again over here, it just checks from the walk state. If it's on, they just press the thing, we're here, and they pressed UI accept or spacebar and they're on the floor, then we're going to go ahead and go to this jump. And otherwise right here, if they're not on floor, then we need to go to state fall over here. We need to transition to that one. And then going down to fall, it's one check is whether or not we need to go down to walk there. And otherwise we want to just go ahead and run the little fall code. And again, to remind you up here on the walk, the reason there is no specific walk code is because all walk needs is this move left and right stuff up here. But these other ones, fall for instance, just a reminder, it moves left and right as well as pulling us to the ground with this code. And then if we go to jump, we can check if it's not on floor, then we want to fall. And otherwise we want to do the opposite of falling, right? We want to go ahead and jump. And then of course up here, like with the rest of them, it's going to move left and right as well, like I can do when I hit play, and I'm going to jump and hit left and right really quick after I hit the jump button. And then the same thing, I'm going to fall and move left and right. So we can see, and then of course left and right works on the ground as well. And finally move left and right no matter what. It just comes in here and it gets the access. It basically looks if this key, or we could even assign a joystick to load up that value, or we could not. In this case we just have the keyboard, right? So yeah, that it just basically looks and sees if either of these are like, I guess 1.0, and then it subtracts them from each other. So if this one's like, if we're using an analog joystick, it might be like 0.5 and this one might be 0. And in that case, maybe we only want it to like go real slow to the left and right, so that's what it's going to do. But with a keyboard or something like that, it's either like all or nothing, so it's probably going to be 1.0 or 0 for both of them. And since we can push both keys, pushing left and right in theory should zero it out. So I'm going to push both of them at once, left and right. Nothing's happening. But if I let go of one, now it's moving in that direction. But pushing both of them, it doesn't move because it subtracts one from the other. And I guess if it's negative, it's going to go left, and if it's positive, it's going to go right. Whichever one has the most momentum or magnitude or whatever, so to speak. But yeah, it just loads up this variable direction with those values. If that direction variable is non-zero, then it's going to say that the velocity gets, that 1.0 or negative 1.0 times speed up here. So we could fine tune that, of course, by if we want them to move a little slower, a little faster, whatever, we could change that to like 100. If we want them to jump a little bit less, we'll change that to 200. And then those are going to be factors here that end up getting worked into the thing. And then this one's having the player slow down if there's no direction being pressed, pretty rapidly slowing down. Okay, we'll do one last check with those slight adjustments, but otherwise that's that. That's how simple a state machine is. See how it's barely moving now that I shrunk down those values, just in case you weren't quite aware of how the full circle of all that worked. So yeah, it is technically more complex than the initial code. As you can see, it's probably taking up twice as many lines or so, which that's the whole trade-off. But once you get, I suggest sticking with the inline if-else statements like they give you pretty much, and try and get a little bit of distance doing just that. Because if you're new to like programming in GDScript or anything, and these basic concepts and principles can be applied to like potentially other game engines and just regular game development without an engine. For the most part, it's the same. But yeah, try and stick with the inline stuff first, and kind of do that till you hit a wall, till you feel like, oh man, I have all this spaghetti code of like it doesn't take too long to get that far. And then you're like, oh, I need to start setting Boolean variables and like, doing all this complicated stuff. And maybe you might even go that far and even do that, which I definitely recommend like save off a zip of your folder before you make all those changes so that you have like a clean base to roll back to if you need to. Yeah, and then when you go in, like even if you get that far with the inline code, and then you go in to make a change, and like, oh, I actually want to make it so they can turn left and right and shoot in the air or something. It's like, oh, forget about it. It's gonna get crazy complicated, right? Most likely. So yeah, once you start feeling yourself bumping into those issues, that's when all of a sudden this code's a lot nicer because again, the format that will probably stay about the same for your physics process. You can add new states and just remember, go draw them out. Even if you have more states, draw those out in the big picture of things. It might take a few tries or whatever and some careful thought, but shouldn't be too big of a deal. And then you put your terminating cases at the very top there before the actual fall code or action code, so to speak. Got the terminating case, that the otherwise action code, and yeah, just go from there. And if you have any questions, please leave me a comment about it, and if I notice it, I'll definitely be happy to look into it. Thanks for watching. Have a good one.